both the graphs have same x and y axes. This is accelerating potential here, retarding potential over here. Alright. Similarly here also this is accelerating potential and this is retarding potential. Alright. So this is reverse terminal and this is normal terminal. Here also it is normal terminal and this is reverse terminal. Alright. So that's what you have got to keep in mind whenever you are observing these two graphs. Alright. Now let's understand the effect of frequency. We already saw effect of intensity on photocurrent. Now we intend to observe the effect of frequency on photocurrent. Alright. So we changed the intensity in earlier situation. Now we are changing the frequency, h nu. So the energy is increased. So in this case, we have got frequency 3, 2 and 1. Frequency 3 being greater than frequency 2 being greater than frequency 1. That's the situation. We already had derived this equation where h nu is equal to h nu 0 plus Ke. This was the work function. This was the energy required to strip an electron. So h nu coming from here, falling on this, it's consuming h nu 0, that is work frequency or threshold frequency, threshold energy to strip electron from this metal, and whatever energy left is given out as kinetic energy. For example, suppose there is 200 joules coming over here, and out of that 20 joules is being used for stripping electron. So that is the threshold energy, 20 joules. So 180 joules is involved for kinetic energy. So that's how it works. That's how the equation h nu is equal to h nu 0 works. 200, 20, 180. Alright. Now if I say frequency is greater, now suppose that was that 200 example. Now in this case frequency 3 is much greater than frequency 1. So the metal is the same, but here the energy is much higher. This frequency is highest. So because of being highest, say it h nu generated here is 400 joules. Alright, now this 400 joules falls on this plate, photosensitive emitter, and the energy required is the same, 20 joules. Alright, since the metal is the same, so 20 joules is the energy involved. So what is left is 380. So 400, 20 taken for stripping of electron or threshold energy, and what is left is 380 joules. So kinetic energy obviously would be more in this case because more energy, and for both the cases same threshold energy, so more energy, so more kinetic energy for this, less energy and less kinetic energy for this. So obviously we can expect that if kinetic energy is more or kinetic energy is less, when we use commutator and when we reverse the potential, the electrons when move there would be moving with same higher kinetic energy, would move with higher velocity, and lower kinetic energy would move with lower velocity. So when it is moving with higher velocity, the stopping potential also required would be higher. And when it is moving with lower velocity, stopping potential required also would be lower. Alright, now let's see whether it's clear from graph. Yeah, now in graph, what happens is, when we are doing this, at that time what we find is, for whatever frequency we are using, the source, the monochromatic source, whatever frequency we are using, lower or higher, we find that its saturation current is the same for all three. There's no differentiation, whether it be highest or whether it be lowest frequency. The saturation current is the same. So that's one thing that we observe. Now let us see what happens when we use commutator and reverse the potential, interchange the potential now. So that is what is this reverse terminal. All right. So this one which is there is for frequency 1 and this one is for frequency 3. We are finding here that the stopping potential for frequency 3 is much greater than stopping potential for frequency 1. And obviously we already expected this to be highest because kinetic energy was highest in this case and lowest in this case because kinetic energy was lowest. So for highest kinetic energy you require higher stopping potential to stop the electrons from passing out. Alright, so this is what the graph represents. Alright, so what we conclude is with frequency, with change in frequency, saturation current remains the same, but stopping potential is different. For higher frequency, higher is the stopping potential. Alright, whereas in case of intensity, we found that in case of retarding potential, we found that no matter whatever be the intensity, the stopping potential was the same. Whereas with difference in intensity, we found that the photocurrent generated was different. For higher intensity, higher photocurrent was generated. For lower intensity, lower photocurrent was generated. Alright, so please keep these things in mind for your MCQ purpose. Alright.